Hello everyone, myself Prasantami Kundu. I welcome you all to this lecture of soft computing techniques. This is the first lecture of module 11. So, in today's class, we'll try to understand some concepts on rough set theory and introduction to rule generations. So, consider a decision table. Here, the objects are U 0, 1, 2, 3, 4, 5, 6, and some attributes are A, B, C, D. These are the conditional attributes, and E is the decision attribute. So you can write E is a decision attributes. So here the value of conditional attributes for object 0 is S, B value is R, C is T, D is T, and conditional value is R. Similarly, for 1, the values are R, S, 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 T. For 2, values are T, R, R, S, S. For 3, values are S, S, R, T, T. For 4, values are S, R, T, R, S. For 5, values are T, T, R, S, S. For 6, values are T, S, 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 T. For 7, values are R, S, S, R, S. So here the indissociative relation for attribute B. So for attribute B, so B, take care B. So values are R is 0, 2, 4, S is 1, 3, 6, 7, and T is 5. So here you can say the values of indissociative relation for B are equivalence classes are 0, 2, 4, 1, 3, 6, 7, and 5. Similarly, for indissociative relation for the attribute C is 0, 4, 1, 6, 7, and another equivalence class is 2, 3, 5. So let P is an attribute which contains B and C. Now how to find that indissociative relations of P with the help of these two attribute indissociative of B and C. So here let P equal to BC. So the indissociative relations for P, that will be indissociative relations of B, some operations with indissociative and C. So first to find indissociative relations of B, which is given here, indissociative C. So with the help of these two indissociative relations, we can calculate the indissociative relations P, which contains both attribute B and C. So here the formula is that indissociative relations of P equal to indissociative relation of B, some operations of indissociative C. This operation is defined as A operation B is the X intersection Y for all X belongs to A, for all Y belongs to B, and X intersection Y is not the null set. So here indissociative relations of P is indissociative relations of BC, so that is the indissociative relations of B, is indissociative relations of C. Now you need to do that condition is that X belongs to A, Y belongs to B, and X, Y is not equal to null set, then we will get this intersection elements. So you will get the intersection element XY. So here 0, 2, 4 and 0, 4. So element is 0, 4. 0, 2, 4 and 1, 6, 7. Nothing. 0, 2, 4 and 2, 3, 5 intersection is 2. For here 1, 3, 6, 7 with 0, 4 nothing is there. 1, 3, 6, 7 and 1, 6, 7. So that should be 1, 6, 7, 1, 3, 6, 7 and 2, 3, 5. So there should be 3. Now with 5 it is null set and here it is 5. So that is 0, 4, 2, 1, 6, 7, 3, 5. So the indissociative relation is 0, 4, 1, 6, 7, 2, 3, 5. You can check it indissociative relation of B and C. So B and C here are T, so are T 0, 4, then 1 SS, 6 SS, 7 SS, and rest all are different. So we have solved these questions that where indissociative relations of B is given, indissociative C is given, we can find indissociatives of P, where P is the P set content both B and C. So this is the concept I hope you understood this concept. Next is that we know that lower approximation or upper approximation. So lower approximation contain the equivalence classes, which is totally subset of the target set. Upper approximation not intersection not the null set. And also you have studied that positive region of the partition U by D with respect to attribute P is the positive region of D written as these things. So here the positive region of partition U by D with respect to P, that is the union of all the lower approximations. So here two more definitions are there. So first one is a negative region. So negative region of the partition U by D with respect to attribute P is written as negative D P, that is equal to total set of objects. So here U is the set of all objects, minus upper approximation. So first to find upper approximation, take the union. So that is the negative region. And boundary region of the partition U by D with respect to attribute P is this set minus the positive region. So now try to solve one question for that. So we have here indissociative relations P, which is 0, 4, 1, 6, 7, 2, 3, 5. Let the Q is the decent attribute. So indissociative relation of Q is, so come here, the Q is here the 0, then 1, 3, 6, 4, 5, 7. So this is the indissociative relations of Q. 0, 1, 3, 6, 2, 4, 5, 7. So here x1 is this thing 0, x2 is 1, 3, 6. So need to find lower approximations, upper approximation, etc. So check it. So for the positive region, so now that x1, so x1 is the set which is 0. So here you can write that lower approximations P x1. So nothing is the subset, target set is the 0. So nobody is subset of that. So here is null set. Now at 136. So 136 you will get here 3. So px2 is 3. Then 2, 4, 5, 7. So 2 is a subset, 5 is a subset. So here lower approximation of x3 is 2 and 5. So positive region is union of all this. So we got 2, 3, 5. Similarly, for the upper approximations, so that is x1. So x1 is 0, 4. So just check it here for upper approximations. So p upper approximation x1, so that will get 0 is a subset of these things. I mean, this is the target set and intersection is not null, so here we'll get 0, 4. So here we'll get the upper approximation is 0, 4, then 1, 6, 7, 3, then 2, 0, 4, 1, 6, 7, 5. So this is the union of all upper approximations. So here negative region is set of all objects minus these things, so that is null set. Boundary region of the partition with respect to attribute P is the difference of union of all upper approximations minus the positive region. So you will get these things is 0, 1, 4, 6, 7. This means the object this 2, 3, 5 can certainly be classified as belonging to a class in attribute E when considering attribute B and C. Next is that feature dependency and significance. We know that Q depends on P in a degree K, where K lies belongs to 0 to 1, denoted as P imply QK. If the value of K is the cardinal number of positive region of U by Q with respect to attribute P, the total number of objects. So here it is the value of K is there, that the positive region of U by Q with the respect to attribute B and C, that is the 2, 3, 5 U, so it is 3 by 8 here. Here Q can be written as the E. So while a feature is removed from the set of considered possible features, an estimate of that feature can be obtained. The higher of the change in dependency, the more significant the feature is. If the significance is 0, then the feature is dispensable. Significance can be defined as significance P attribute QA is the gamma of Q with respect to P minus gamma of Q with respect to P minus A. So here is, for example, you have to take in P equal to ABC and Q is E. So we have calculated the gamma BCQ, that is 3 by 8. Similarly, you can calculate all these values, gamma ABCQ, gamma ABQ, gamma ACQ, etc. So here the value of sigma PQA is the value of sigma PQA is 4 by 8 minus 3 by 8. So total ABC minus BC, so that is 1 by 4, and remaining are 4 by 8 minus 4 by 8, so 0, that is also 0. So what we can say here, we can say that attribute A is indispensable and other two attributes B and C are dispensable. So redact let R be a subset of initial attribute set C such that for a given set of attributes D, that the value of gamma RD, that value is equal to the gamma CD. So R is a minimal subset if gamma R minus AD is not equal to gamma RD for all A belongs to R. This means that no attribute can be removed from the subset without affecting the dependency degree. There may be many redact sets for a given database, so that can be written as R all, so that is X, where X is a subset of the all attributes C, and gamma XD equal to gamma CD, and gamma X minus AD is not equal to gamma XD for all A belongs to X. The intersection of this R all is called the core. A reduct of minimal cardinality is ideally searched for. That is, an attempt is to be made to locate a single element of the reduct set where R minimum is the subset of R all and R minimum equal to the X belongs to R all. For all Y R all, the cardinal number is less than that. So cardinal number of X is less than equal to the cardinal number of Y. Now one is quick reduct algorithm, so that is quick reduct CD. So C is the set of all conditional attribute, D the set of decision attribute. So initially assume R equal to the null set, do assign the value of R in a set T. So for all X belongs to C minus R, if gamma R union XD is greater than gamma TD, so you write it T equal to R union X, then assign this value R, assign T to R until these two regions are same and return R. You can take one example and try to understand the quick redact algorithm. Now we are going to understand the introduction to the rule generation. So how to make a rule. So here the table 1 is that patient, which is P1, P2, P3, P4, P5, P6. Here is the H means for headache. H means headache. Then M for muscle pain. And T for temperature. So here patient P1, headache is no, that muscle pain is yes, temperature is high, flu is yes. For patient 2, headache is yes, muscle pain is no, temperature is high, flu is yes. For P3, headache is yes, muscle pain is yes, temperature is very high, flu is yes. For P4, headache is no, muscle pain is yes, temperature is normal, flu is no. For P5, headache is yes, muscle pain is no, temperature is high, flu is no. For P6, headache is no, muscle pain is yes, temperature is very high, flu is yes. So that is the whole table we have calculated, and we have also seen that the dependency attribute for T imply flu is K is half. For H imply, the headache imply flu, K is 0, and M imply flu, K is 0. That, and we also calculated that T is a core attribute. So now we are rewrite the table. So this table can be written as, we just keep the temperature and any one attribute. So first we keep the attribute headache. So patient 1, headache is no, temperature is high, flu is yes. For patient 2, headache is yes, temperature is high, flu is yes. For P3, headache is yes, temperature is very high, flu is yes. For P4, headache is no, temperature is normal, flu is no. For P5, headache is yes, temperature is high, flu is no. For P6, headache is no, temperature is very high, flu is yes. So this one table, now we can make one first rule is that if headache is no, temperature is high, flu is yes, you can write other 5 rules. Okay, so it can be, the table can be written as with headache, with we have written here headache and temperature. Now muscle pain with temperature. So the table, for patient 1, temperature is high, flu is yes. For patient 2, muscle pain is no, temperature is high, flu is yes. For P3 is yes, very high yes. P4, muscle pain is yes, temperature is normal, flu is no. For P5, muscle pain is no, temperature is high, flu is no. For P6, muscle is yes, temperature is very high, flu is yes. So one rule you can write that if muscle pain is yes and temperature is high, flu is yes. Rule 2 you can write like that, that if muscle pain is no and temperature is high, flu is yes. Similarly, you can write the other rule. So we'll learn a lot about these topics. So now in conclusion we can say today we have understood some concepts on Raph's theory, some concepts on Raph set theory. We also learn the basic concepts of rule generations. So question is that, so in this class we have calculated the value of gamma, B, C, you can write here E. So you calculate the following things. Value is given just to verify these things. A, B, C, you can write it E. Calculate this value, you calculate this value basically 3y, 8. This is also 4y. So calculate all the values here. A, C, E, and 4 gamma, A, B, E. Calculate all these values. So these are the references of today's class. Thank you.